In this video, we're going to do some practice naming compounds and writing formulas of compounds. And we'll use this flowchart to start. So we're starting with ZnCl2. And the first question is, does the compound start with a metal or NH4+, or does it start with a nonmetal, or actually a metalloid could be over here too? Well, Zn is a metal, and so we will name it zinc. And zinc is something that you don't need the stock system for. It's one of the exceptions in the D block. So we just use the binary ionic naming convention of naming the metal followed by the nonmetal. So I will name it, it's zinc chloride. And it's that simple, actually. There's nothing more to it. That is an unambiguous way of identifying the compound. You say to me zinc chloride, and I will know that the zinc is only ever going to be +2, the chlorine is only ever going to be -1, and that the ratio has to be 1 zinc to 2 chlorines. I would get this formula straight from this name. Next, we have Cl2O7. And so because the compound starts with a nonmetal, chlorine, we know it's a molecular compound. And because it doesn't start with an H, we know it's not an acid. So we're going to have to use the prefix system. And the prefix for 2 is di. So we will say this is dichlorine. And the prefix for 7 is hepta. So we say dichlorine heptaoxide. Next, we go to HClO4. And because H is a nonmetal, we go to the molecular side of the flowchart. Because because it starts with an H, we know it's an acid. And now we need to figure out which option. Is it binary or ternary? Well, because ClO4 is a polyatomic anion, we know it's ternary. And we can look up the name for ClO4 minus. The name for ClO4 minus is perchlorate, and perchlorate, that ate suffix, becomes ic when we are naming an acid. So we just simply call it perchloric acid. Perchloric acid. Next, we have Na3PO4. Na is a metal, and so we do not need to use the stock system because sodium is only ever going to be +1. So the fact that this is a ternary ionic compound is indicated by the fact that we have not just sodium and phosphorus, but also oxygen. So there are 3 different elements. We would have to either have it memorized or look up the PO4 anion, and it's actually going to be PO4 with a -3 charge. It is phosphate. So we simply name this sodium phosphate. Finally, we have PbSO4. Now, this is something that's it's interesting because Pb, it of course is a metal. It's outside of the D block and F block. It's in the P block actually, but it is something that we need to use the stock system for because lead has multiple possible oxidation numbers. And so what I think is best to do here is to start off by writing lead and leave a blank space for yourself before you figure out the rest of it. Now I see SO4, and if you have this memorized, great, but you might need to look it up. And if you do look it up, it takes a little bit of time. You find that it's sulfate. Now, the sulfate is going to be with a -2 charge. And that's something that, again, you might not have it memorized. And so when you're looking it up, it might take you a little bit of time. So it's important to have that space there, those parentheses there, to remind yourself, wait a minute, you need to use a stock system and you need to, put that in later on. So if I know that the sulfate is -2, and again, you get that by looking it up, the fact that there's one sulfate and one lead, which is +2, I mean, the lead is going to be +2 because there's one lead and one sulfate. If the sulfate is -2, the lead has to be +2. So that's kind of the last step here, that you put in that the lead is with a +2 charge. But I would definitely advise you to write down immediately lead, parentheses, leave space for yourself, then figure out the fact that it's sulfate, then figure out the charge of the lead, just so that you don't forget to use the stock system. Now let's go in the other direction. So hydrosulfuric acid. If it's an acid, we know that there needs to be an H, and so we can write H out in front. The fact that it says hydro in front means that this is a binary acid. So this means that there's only going to be one other type of atom. And the fact that it says sulfuric, it pertains to sulfur. Now, I know that hydrogen is going to act in an acid like the other alkali metals, +1. And sulfur in an ionic compound would be -2 based on its group number. So all I have to do here is use the crisscross method, and I know that I have H2S. I know that this 2 goes here, that this 1 goes here, and we get H2S. Another way of looking at it, if this helps, is to look at it like we have an H positive, we have an S -2. I need to have a second H positive to cancel out the -2 charge. However you want to show this, however you want to visualize this is really up to you. Next, we have tetraphosphorus decaoxide. I see tetra, I think 4. I see deca, I think 10. So tetraphosphorus, I need 4 phosphoruses. I see deca, I know I need 10 oxygens. This, of course, is going to be a covalent compound. Do not think about charges or anything like that. That only applies with ionic. This is your formula for a covalent compound, and it's just telling you the information that you need to know right here. Tetra, 4, phosphorus, P, deca, 10, oxide, O. All right, next we have silver nitrate. So silver, I look up on the periodic table, it's Ag. Nitrate, I either have it memorized or I look it up, it's NO3. Now, nitrate has a -1 charge, and you get that from your list of ions. Silver is one of the exceptions in the D block. You don't get this from the group number, but you have it memorized that silver is only ever going to be +1 in an ionic compound. So I look at the fact that silver is +1, the fact that nitrate is -1, I realize I have a 1-to-1 ratio, so the formula is simply AgNO3. And please leave this as your final answer if I'm ever assessing your work. Chemists will never write ion charges in a formula if it's for a complete compound. You can refer to Ag positive ions or NO3 negative ions, but in a compound of AgNO3, that's the way it should be represented, just as H2S should be represented like this and P4O10 like this. Next, we have chromium 4 sulfide. So what I want to do is write chromium is Cr. I know that it's +4. I know this because it says so. Sulfide. Well, we talked about it before. Sulfur, being in the same group as oxygen, is going to form a -2 anion. Now, I can take the crisscross method and get to Cr2S4. But if I do that, I have to realize that 2 and 4 are both divisible by 2. So this is just Cr(S)2. 1 chromium for 2 sulfides. And there's my answer. Another way to do it is to look at it like I've got a chromium, it's positive 4. I've got sulfide. I know it's negative 2. And I realize that I need more negatives. And I realize that, okay, a second sulfide will make us have negative 4 charge overall to the positive 4. That's the chromium. They cancel out. So CrS2. Finally, we have sodium nitrite. Sodium is Na. This is going to be an ionic compound because it has sodium, a metal. So we have Na. I know it's a group 1 metal, so it's going to be positive 1. I have nitrite. Nitrite, I have it memorized or I look it up, but it's NO2 minus. If it were IDE, IDE, totally different scenario. But the fact that it ends in ite indicates this is going to be a polyatomic ion. Anyway, I've got Na plus, I've got NO2 minus. I realize that they should be in a 1-to-1 ratio, so I simply write NaNO2. And that is my final answer. Hope this video has helped. Please feel free to leave any questions or comments in the comments section below. Thanks for watching.